Hello, YouTube. This is UMails03. So in the previous two lessons, we talked a lot about generators and this idea of a function that basically yields something. And so it yields something so that we can basically iterate through the values over whatever's being yielded. But if we just want to print what's being yielded, we would have to turn it into basically a list or a tuple in a set. And we've already seen, I think, enough examples of that in the previous videos, except we're actually going to see one more. So in this video, we're going to talk a little bit more about generators, and then we're going to talk about list slicing. How do we access particular elements of a list or tuple, depending on what their index positions are? And we can specify what the range is going to be for particular index positions of the elements that we want to retrieve. We're also going to talk about a different way to format strings. Another way to format strings. We saw another method a few lessons ago, a few lessons back, about how you could basically put integers into curly braces, right? And then you could have a string, and then you would call dot format of, and then you would specify, what string, whether it's a variable or a string literal, an actual string, corresponds to each of the 0 and the 1 and the 2 that you put into the curly braces of the string. But we're going to see that again, and then we're also going to talk about inner functions, which is basically when one function is defined completely inside of another function. And if you have a good memory or a good recollection, or if you've seen the videos on lambda functions or intermediate functional programming, we've already seen an example of that. So anyway, we're just going to scroll down. So we have a generator called generate something of t. Okay, and we don't have Java docs here, but we know how to do Java docs. So on your own, if you're a good software engineer, you would get into the habit of putting documentation underneath this function header. It's going to be a multiple line comment that specifies what the function generates, what it accepts, and what it yields, right? So then this will be myTuple, and it has 6 tuple values in it. What are they? Well, they depend on the value of t. So it's going to be t plus 1 at index position 0, t plus 2 at index position 1, and so on. And then we're going to say for every element in myTuple, yield that element. Okay, so then we remember this, right? Where essentially if we go ahead and run main.py, we just get this generator object, right? But then if we go ahead and print each of the values that's generated, then it's no problem doing that, right? So 10 plus 1 is 11. 10 times 4 is 40, right? So that's why you're getting those values there. And then obviously you could go ahead and convert it to a tuple if you want. And it looks like we're not printing that tuple, but it would basically look a lot like myTuple, right? So you would just put the values back into a tuple. So then if you go ahead and say print of s, we can go ahead and do that. And then you get 11, 12, 20, 13, 8, and 40. And that lines up with this tuple for a value of t equals 10. Let's do one more. We said that we can also generate different data types. This one actually generates different dictionaries. It's going to generate V dictionaries. And the question is, what's the length of each dictionary? It's just going to be 3. Okay, so each of these dictionaries is going to be the same as the next one. But I just wanted to show you, the lesson here is that we can generate elements of any data type. And here the example to illustrate that is with dictionaries. So hopefully you can see that word. It might be getting a little bit cut off there. But that's dictionaries, right? So if you have for u in range of v, okay, so we know what range of v does. So it's going to, do this code v many times, right? So it's going to start out with an empty dictionary, and then it's going to say my dict of apple is equal to r of 0, 10. What is r? Well, in a previous lesson, we've already talked about how we can use modules, right? So let's scroll up and look for a function called r. I'm not seeing one. The only thing I see is this line 1, which says from random, import randint as r. And we've already talked a couple of times about how if we import a module, we have access to the functions within that module. And we said that the randint function basically accepts 2 integer inputs and returns a random integer between those 2 extremes, okay? And it could include either extreme. So if you say randint of 40, 42, it could return 42, okay, not just 40 or 41. So hopefully that makes sense, okay? So what we're going to do, so this one would just generate random integer between 0 and 10, right? For the value that's associated with the key apple, okay? For the value that's associated with banana, it'll be a random integer between 10 and 20. For cantaloupe, it'd be between 20 and 30, and then we're just going to yield that dictionary. So we're just going to yield this dictionary, which has now 3 key value pairs, okay? Because it started out as an empty, and then we added 3 values. We declared 3 values, and we said that you can just specify what those are, and the dictionary just adds them on, okay? And then we're going to say for s in generate dictionaries of 4, okay, so we're going to pass in the value v equals 4, so this code would run 4 times if we were going to call the generator. And then there's a nested for loop, okay? So basically, for what is s here? So for S in generate dictionaries of 4, okay, so we're talking about this. Basically what happens is the S corresponds to one of the dictionaries that's being yielded by the generator. Okay, so S is a dictionary. And then so it says for T in S dot items, and you might remember from a previous video, if you call dot items on a dictionary, this is another generator, and it generates tuples for the key value pairs, within the dictionary. So it would generate one tuple where the first index position is apple and the second index position is a random integer between 0 and 10. It would generate another tuple where the first index position is banana and the second index position is a random integer between 10 and 20. So hopefully that makes sense to you. That's what S dot items does, and that corresponds to a particular dictionary. Okay, and then what we're going to do is we're going to say T is that particular tuple, because S dot items generates those key value tuples, and so T is a particular key value tuple. Okay, and so T of 0 would correspond to the, the element in this index position 0 of the tuple. So that's the key, because we're calling S dot items. Okay, and T of 1 would be the value. So it would say for this item, and then the key of that key value pair is mapped to, and then the value of that key value pair. And then we already ran the code, so I'm just going to scroll down, and you can see, so this is for the first S. This is for the first dictionary, okay? And it ran 3 random integers, okay? And it's just gonna, and then for each value of T, so every value of T here is a line. This would be basically one of the key value pairs, and then another value of T, and then another value of T, okay? And then it stops this inner for loop, and then it goes on to the next dictionary. So then it yields the next dictionary, and then it iterates through each of the key value pairs. So it's basically calling a generator within another generator. So hopefully that makes sense to you. All right, 7 minutes in, let's talk about list slicing. So basically elements, so we know we're already familiar with a list comprehension, right? So we could say something like list comprehension is equal to f of z for z in myList if b of z, right? You could say some list, right? And we could say something like 2 times z for z in myList if, and then you could say something like 40 is less than z is less than 50, okay? But you can also specify particular index positions that you want to return. So if you have a particular list or tuple, remember those are the 2 types of data structures that you can access by index position. You can still access elements in a dictionary, but you wouldn't just pass in an index position, you'd pass in a key, right? And so then for our example that we were talking about, you would pass in not like a 2 or a 0, you'd pass in apple, okay, because you'd pass in a key. But anyway, list of A just obviously returns the element at index position A. If you say list of A colon B, this returns the elements at all index positions between A and B, okay? And A would be included and B would not be included. So let me show you what I mean by that. What we're gonna do is we're gonna say Y is equal to list of range of 20. And we know what that is, right? That's gonna be a list with the elements 0, 1, 2, 3, up to 19. We're familiar with that. And then what we're gonna do is we're gonna say print Y of 10 and 17, okay? So we know that if we do list of range of X, okay, the elements in list of range of X line up with their index position. So for example, we know that index position 0, right? We would say Y of 7 is 7, right? So hopefully that makes sense to you. So this is going to give you 10, 11, 12, 13, 14, 15, 16. So we can go ahead and run it and you can see that there. So hopefully that makes sense to you. And then if you just say, if you say list of just A colon or tuple of A colon and you leave B blank, then by default, it's going to go to the end of the list or tuple. So it would just be K greater than or equal to A. If you leave the first position blank, but you just specify the second, it's going to return all index positions that are less than that second. Okay, so we can go ahead and run it. So then what if we just said Y of colon 17, it would just give us 0 up to 16. So hopefully that makes sense to you. And then if we just have neither of them specified, list of blank colon blank, that would just give you all the elements in the list. If you have tuple or list of A, B, C, what it does is it starts at index position A, and then it increments up by C every time, but the Boolean that it checks is whether K is less than B. So as long as K is, by the time K is no longer less than B, once it's at least B, then it will no longer return those elements. So hopefully that makes sense to you. So we can go ahead and do something like, what if we do 5, 10, 3? So it's going to return the element at index position 5. and it's going to return the element at index position 8, but it does not return the element at index position 11 because we're just going up by 3s, and 11 is not less than 10. So you just get the 5 and 8. And even if you had made that in 11, remember, the Boolean is a strictly less than or greater than, so you get the same thing. Okay, and then if you make this value negative, then it's going to start at k equals b, and you're going to go down by c every time, or by, negative c. If it says -2, you go down by 2. Okay, and then the Boolean to check is whether k is still greater than a. If you say list of a colon blank colon c, then this would just, start at index position a and increment by c to the end of the list. If you say list of a colon blank colon negative c, it would start at index position a and go down the list. It would go down c index positions every time, until you just reach the beginning. Okay, and then if you say list of blank colon b colon c, it would start at k equals 0 and it would go up in increments of c, and the Boolean it would check is whether k is less than b. If you say tuple of blank colon b colon negative c, what would this do? So it would start at the very end of the list and it would go down c index positions every time. This is your decrement, and the Boolean that it would check is whether k is still greater than b. So maybe that would be a good one to show an example of. So then what if we go ahead and do something like, let's go ahead and do something like, I realize we might only be talking about string formats in this video and probably leave inner functions and decorators to the next video. But the one that we're trying to demonstrate here is, what if you had something like, so we're going to leave this one blank, and then we could say 10, and then we could say -3, so something like that. So then we can go ahead and run it. Okay, so then this would give you 19, 16, 13, because it starts at 19 basically, and it decrements by 3 every time. So hopefully that makes sense to you. Okay. And then if you had set a 13 here, well, then it checks, okay, is the element still bigger than 13? And 13 is not bigger than 13. So hopefully that makes sense to you. Okay, and then that was this one, right? And then what if you leave the first two blank? So if you say tuple of blank colon c, so then this would just increment, k equals 0, k equals c, k equals 2 times c. It just go up in increments of c, okay? If you say -c, it would start at the end of the list and go down in increments of c. If you say tuple of a, b, and you leave the third one blank, that's the same thing as tuple of a, b. If you just say tuple of a blank blank, that's the same thing as tuple of a blank. If you say tuple of blank b blank, that's the same thing as tuple of blank b. Okay, so you know what these means, right? This would just be like a less than or equal to k less than b, right? A less than or equal to k. This would be k less than b, and then this would just be everything. This would be, same everything. Okay. So hopefully that makes sense to you, and we saw a couple of examples, but if any of that's unclear, you should go ahead and just keep playing around with it. So what would this do? So this would do 18, 14, 10, 6, 2. Okay, so then if you go ahead and run that, then those are the numbers that we see in a list. Okay, what if we had made this a tuple? Could we have said tuple of range of 20 and sliced it like this? Yes, absolutely. Okay, so then we would just get a tuple instead. Okay, and so this is called list slicing. And that's the general term, but just remember that it can also apply to tuples. So I guess theoretically you could call it tuple slicing. What we're going to do now is we're going to talk about formatting strings. Okay, so let's think about 3 string objects. So we have A equals apples, B equals and C equals oranges. Okay, and the goal is to print a string that says apples and oranges. Okay, so there's 3 different ways to do that. Well, there's a 4th, naive way, and that's print apples and oranges, right? But no one would type that out if you had these 3 variables on these lines. So what you do is you could either say print string of A plus string of B plus string of C, okay? And you would say, well, those are already strings, so why do I have to say string of A plus string of B plus string of C? And then I'm going to explain that to you in a second, but basically what I'm going to try to drive home here is that, anyway, I'm going to try to explain that in a second, but you could basically go ahead and say something along the lines of A plus B plus C. So this is simple concatenations. This is a concatenated string using the basic approach from the beginning of the curriculum. We also said a few lessons ago that you could go ahead and basically have index positions that refer to the ordering of arguments that you pass into this format function. Okay, and these arguments are applied at the positions that you specify in the order that you specify. So since this one says, print 0, 1, 2, it would just go ahead and stick those things in where they belong. So it would say apples and oranges, right? If you wanted to still say apples and oranges, but you made these 2, 1, 0, you would have to change the ordering of the way the arguments appear. Okay, so hopefully that makes sense to you. What I wanted to do is that I wanted to also tell you about an even simpler way to format a string. There's an even shorter form way to do it. It turns out that you can actually say print of, and then if you say before the double quotes, if you have a little f, what that allows you to do is it allows you to make a string where if at any point in that string you have curly braces, what's inside of those curly braces will be taken to mean its literal value rather than the string representation of it. So let me give you an example of that. We're just going to do a little example here. I'm just going to go up to the top of the file, neglecting comments and import statements. So what we're going to do is we're going to go ahead and say something like a equals, or we can do different ones. So we could do something like var1 equals brownie, var2 equals pie, and var3 equals cookie. Okay. And then what we're going to do is there's 2 different ways to do this, right? So we're going to try both methods, okay, for basically formatting, having a formatted string. So we already know one way to do this, right? We could just concatenate, well, we need brownie and pie and cookie, and that would be fine. But then we said that there's another way to do this, right? So we could also go ahead and basically make a string object, right? So you could, and if it makes you more comfortable, you can put parentheses around the string objects and then call format on the entire object. But the goal here is that you're going to take a string and then you're going to call the format method on that string. And what is this type of string? Well, it's a type of string where we have curly braces inside, with integers inside curly braces in a particular order where the integers correspond to the ordering of the arguments that are passed in. So brownie and then we could say maybe 2 or 1 and 2, right? And you just have to make sure it's consistent. So you would say, okay, well, if I want brownie to show up first, right, I have a 0 here, right? So that means that brownie needs to show up first in the arguments, right? And then if you have a 3, okay, well, 3, I need and to be at position 3. So let's just go ahead and make a couple of commas and put var4 here, okay? Because I know that and has to show up at position 3, which is really like the 4th argument because we start at position 0. Okay, and then what about this 1 here? So then I guess the next word that I would want is pie, right? So that means that var2 has to go at index position 1 of the arguments, right? Sorry, I shouldn't be saying brownie here. Obviously, I should be saying var2, right? And then you could go ahead and say, okay, well then what shows up at index position 2? So this would be the last thing that we want to print, right? So this would be the cookie. So this would go right here. Okay, so hopefully that makes sense to you. And that would be a way of doing the exact same thing. And we have a Python enhancement proposal, right? So they don't even like that I have parentheses here, but what we could do is delete those. But the whole point of what I'm trying to say is that there's another way to do this. So you could have just said F, and then you can just go ahead and now you can just put the ordering of the variables in according to how you see it. So what's the first thing that you want to print? It was brownie, right? And then the next thing that you were looking for, well, if you compare it to the line above, it was at index position 3. So if you look over at that format function line, it looks like var4 was there. And then if you look up in lines 35 through 38, it makes sense, right? var4 is and that's the next word after brownie, right? So brownie and pie, right? And then you could say and cookie, so var3, right? And then you could just go ahead and close that up. And then this is just another example of what we have going on here. So now if we go ahead and run main.py, and we go ahead and scroll up and you get the same formulation 3 times. The nice thing about this one is that you don't actually have to have all these be strings. So what we're going to do is we're going to make var1 equal to 9 here, and then we're going to see what happens. So var1 is now an integer. This is an integer. And we said usually we have a hard time concatenating an integer with a string. So now if we go ahead and run main.py, there's an issue here. Okay, so there's an issue. So what I'm going to do is I'm going to convert var1 to its string form. So now I'm going to go ahead and run it again. So then the code indeed compiles. So the benefit to either of these format methods is it accepts things other than strings. Okay, and then this is, and then this will be the same benefit as above. But using F might also be more concise. It's a slightly shorter line. So hopefully that was interesting. We reviewed generators, talked about list slicing, and then talked a little bit more about string formatting. We'll talk about decorators in the next video. From myList03, thanks for watching, and please subscribe.